Dear students, welcome to our science episodes. Today we are going to discuss chemical compounds. Chemical compounds. Valency. Did you ever hear about the word valency? It is the number of electrons that an atom gains, loses, or even shares during a chemical reaction. Do you remember in the last episode when we talked about ionic and covalent bond? When we discuss how atoms lose or gain electrons, or even when they share electrons together, the number of electrons lost, gained, or shared by atoms is called valency. So, for example, sodium tends to lose 1 electron, so its valency is 1. Chlorine tends to gain 1 electron, so its valency is 1. Carbon valency is 4 because it shares. The key to determine valency is the electronic configuration of the element. So, for example, sodium with 11 electrons, 2, 8, 1. Sodium is a metal. It's a metal because the outer energy level has less than 4 electrons. It tends to lose an electron to achieve the noble gas configuration. Its valency equal to 1. Oxygen, it's a non-metal, 8 electrons, 2 and 6. It gains 2 electrons to achieve the noble gas configuration. Therefore, its valency equal 2. What is the noble gas configuration? It's filling or completing the outer energy level until it has 8 electrons. Give reason why is the valency of noble gases equal to 0? Of course, because they are inert. They have complete outer shell with electrons. They do not lose, they do not gain, and even share electrons. Here are some elements and their valence electrons. This is a table summarizing some elements with their valency. But some elements have more than one valency, such as iron. Iron, for example, has more than one valency. Sometimes it has 2 valency, known as ferrous, and sometimes they have 3, and it's known as ferric. Now identify the type of element, its electronic configuration, and valency. What if we have element X with 17 electrons, another element X with 20 electrons? For the element X with 17 electrons, we said before that the electronic configuration is the key. So we will arrange the electrons 2, 8, 7. What do you think? It's a non-metal. And it will gain an electron to achieve the noble gas configuration. So it's a non-metal because the number of electrons in the outer energy level is more than 4. And it will gain an electron to complete the outer energy level to become 8. The valency now is 1. What about element X with 20 electrons? We will arrange the electrons 2, 8, 8, 2. Yes, it's a metal because 2 electrons only, less than 4 in the outer energy level. And it will lose these 2 electrons for its outer energy level to be completed with 8. Now the valency is 2. From our previous discussions, we can notice that metals enter chemical reactions and act as metals. So, for example, iron, sodium, magnesium enter the chemical reaction as metals. Oxygen, sulfur, chlorine enter the chemical reactions as non-metals. But we have some groups they enter the chemical reaction as one group. Okay, so the hydroxide group, what is the hydroxide group? It's formed of oxygen and hydrogen together, and they enter the chemical reaction as a group, not as oxygen alone and hydrogen alone. No, they enter the chemical reaction as a group, the hydroxide group. Let's see together. The atomic group is a set of atoms joined together, conducting the behavior of one atom during a chemical reaction. They have their own valency and they do not exist solely. We have the hydroxide group as an example, the sulfate group as an example, carbonate group as an example. So we do not act with the sulfate group in a chemical reaction as the sulfur alone and the oxygen alone. No, it's the sulfate group, it's SO4. The carbonate group also, the CO3. The hydroxide group, it's the OH. And the valency is for the whole group, not for one element. The chemical formula. The chemical formula expresses the number of atoms in a molecule and their types. So, sodium chloride molecule is the table salt. It is written as NaCl. It is composed of two atoms of two elements, sodium and chlorine. The chemical formula of water is H2O. It is composed of three atoms of two elements, hydrogen and oxygen. Steps to write the chemical formula for a compound. We write the name of the compound in words, and then we write the symbol for each element. And then we write the valency down to each symbol. All numbers are to be shortened as much as you can. And then we interchange the written numbers. And remember that digit 1 is not written. Let's take an example. Magnesium oxide. This is the first step. We write the name of the compound in words. Then we write the symbol of each element. So magnesium is Mg and oxide is O. We write the valency down to each symbol, so we know that magnesium will lose 2 electrons, so the valency is 2. Oxygen will gain 2 electrons, so the valency is 2. We write the valency down to each symbol. And we are shortening the numbers as much as we can. So if we divide by 2, it will give us 1 here and 1 here. And then we interchange the written numbers. But if the numbers are shortened to 1, the digit 1 is not written. So we write it magnesium oxide without any numbers beside the elements. Let's have another example for clarification. Aluminum sulfate. This is the name of the compound in words. Number 2, the symbol for each element. So aluminum and the sulfate. And remember that the sulfate is an atomic group. We treat it as a group. We will write the valency of the aluminum under it, which is the 3. The valency of the sulfate group, which is 2. And then we will interchange the digits. So we will put the 2 under the aluminum and the 3 under the sulfate, and it will be written like this. Aluminum with 2 of the sulfate and the sulfate group with the 3 of the aluminum. Please note that the chemical formula starts with a metal element, like magnesium oxide. The metal comes first. Aluminum sulfate, the metal comes first. Or the hydrogen. or the positive atomic group, and it ends with the non-metal. So the chemical formula will end with a non-metal or a negative atomic group. So it starts with a metal, a hydrogen, or a positive atomic group and ends with a non-metal or a negative atomic group. This is the way to write a chemical formula. Now let's do some practice. Write the chemical formula for each of the following. Aluminum chloride. This is the written formula. This is the symbolic. Aluminum, Al, and chloride is Cl. This is the valency. Aluminum valency is 3 and chlorine is 1. We will interchange the numbers, so we will put the 1 under the Al and the 3 under the Cl. Here we go, aluminium chloride. Carbon dioxide, the written formula. Then the symbolic formula, the C and the O. The valency of the carbon is 4 and the valency of the oxygen is 2. But we have to shorten these numbers. So if we divide by 2, the 4 becomes 2 and the 2 becomes 1. So 1 under the C and 2 under the O. And please remember that the digit 1 is not written. So it's CO2. Another example, sodium carbonate. This is the symbolic formula, Na for sodium, CO3 for carbonate, and the valency, 1 for sodium, 2 for the atomic group carbonate, and then we will interchange the digits and write it as Na2CO3. Now, write the valency of iron in the following compounds. Fe2O3. What do you think the valency of iron? Yes, it's 3. The number written beside the oxygen. Because remember, we interchange always the digits. What about this? Valency equal 2. Because the digit, if it is 2 and 2, and they are shortened to 1 and 1, the digit 1 is not written. Now it's time for some questions. Give reason for. The chemical formula for water is H2O. This is because hydrogen valency equal 1 and oxygen valency equal 2. Therefore, 2 hydrogen atoms combine with 1 oxygen atom to form a water molecule. Give reason. 1 calcium atom combined with 2 chlorine atoms to form calcium chloride molecule. This is because calcium valency equal to 2 and chlorine valency is equal to 1. Now write the chemical formula for each of the following. Sodium sulfate. Can you remember the steps? Na2SO4. Aluminum oxide, Al2O3. Potassium hydroxide, KOH. Silver chloride, AgCl. Now try to guess the scientific term. A set of atoms joined together conducting the behavior of one atom during a chemical reaction, having its own valency and it's not existed solely. Yes, this is the atomic group. The number of electrons an atom gains, loses, or even shares during a chemical reaction. Valency. Thank you. Dear students, thank you for watching. See you later in other science episodes.